In this video, we will be performing a demonstration for plating thickness over a conductive base. So in this case, the conductive base is going to be carbon steel. So this obviously has magnetic properties. And we know that the realm on the impedance plane of ferromagnetic materials is up when non-ferrous materials are vectored down. We can demonstrate that by taking an aluminum block here. And let's just see what happens when I put my conductivity probe on the aluminum. Now that's where we're used to seeing it when we make conductivity curves. I can quickly take the conductivity sample. We can see ferrites going sort of up, 304 stainless, copper, nickel. Why is that going up? Maybe because of the nickel. Then we got 7075 T6. There we go. So anyway, carbon steel is vectored up, which it's supposed to, and the aluminum is going down. So coating thickness always increases in a clockwise direction. Whether you're putting higher conductive material on a lower conductive base or lower conductive material on a higher conductive base. The only difference is whether it's going clockwise to the right of the conductivity curve or to the left of the conductivity curve. And it's going to keep increasing until the material on the top gets so deep where it's infinitely thick for that test frequency. So let's demonstrate what I mean by that. First, I'm going to clear the screen. I'm going to touch my sample to carbon steel, or my probe to carbon steel, which is going up and to the right. And I'm going to take a very thin sheet of aluminum. Now this is much thicker than aluminum foil, but it's less than 1 millimeter thick. So I'm going to drop that on top of my carbon steel sample and watch what happens to the impedance point. Now, it's going up and to the right because it's still being influenced by the base metal. Because if it was only aluminum, it would go down. But since it's carbon steel magnetic material on the bottom and non-ferrous aluminum on the top, it's still going to go up because the aluminum is fairly thin yet. Next, I will take a second shim and place on top of the first aluminum coating shim. And what do you think is going to happen to that impedance trajectory? It's going to come down because now there's more aluminum affecting this product that I'm testing. Let's take a third shim, put on top. You know that's going to shift down. See? Now I got so much gain in there, it's going to be hard to see. So we're going to just start over. We're going to go carbon steel, 1 shim. This will be 2 shims. This will be 3 shims. We're going to put on 4 shims now. Do you see the thickness curve? As the aluminum gets thicker, it's going in a clockwise direction. And you're going to keep seeing changes in that signal until it becomes infinitely thick. And that's the point at which any further increase in thickness is not going to make any difference on your impedance plane. Okay, looks like I have to get some more shims out of my bag. Adding another one. So just from seeing that, we know we're not infinitely thick yet, because increasing the thickness of the aluminum is still making a change on our screen. But notice the impedance phase angle difference from the first shim to the second shim. It's still pretty big, right? Then from the second to the third, still pretty big, but getting a little smaller. Then from the third to the fourth, you're having less impact. Fourth to fifth, fifth to sixth. So you know when we put this sheet of aluminum on, it's going to be a very small angle change here. Very small. And I'll bet you right there we're almost at infinitely thick. Let's try one more and see if it makes any difference. It does. Wow. Okay. Let's grab another one. Good thing I got a lot of samples. Here we go. Put another one on. We'll see. Maybe. In theory, these things follow spiral locust. I think that's going to be about it, though. So we can see our thickness curve. Carbon steel is up towards the top here. We put on one sheet of aluminum, then another, then another, then another, then another. So that's our spiral coating thickness curve. And this is conductive aluminum over ferromagnetic conductive carbon steel. End of video.